I'm Bob Howarth. I'm a professor at Cornell University in Ithaca, New York. Thank you for the opportunity to talk to you today, and I'm very sorry I cannot be there in person. I was asked to speak briefly about the role of methane from natural gas systems in climate change. The context for that is that the Earth, as you know, is warming. It's actually warming at the most rapid rate ever in the history of our planet, and we're now at temperatures that have not been seen for the last 500,000 years. At the COP21 event back in December of 2015 in Paris, the nations of the world came together and recognized the severe risk that's posed by climate change, and they agreed that we should try to keep the planet well below 2 degrees Celsius above the pre-industrial baseline, with a recognition that 1.5 degrees is a dangerous range. Those were not arbitrary targets. The governments of the world were responding to what the scientific community of the world was telling them. And it may seem that 1.5 to 2 degrees isn't much. It seems like a small temperature. But as we reach those targets, we run a very large and increasing risk of irreversible and runaway catastrophic climate change. There are a variety of reasons why that might be true. Let me just give you an example or two. One is that we're already starting to melt the Greenland ice sheets and some of the Antarctic ice sheets. The Arctic Ocean is melting. That will accelerate as we warm the planet more, and it's entirely likely that those meltings will become irreversible. If we were to decide to start to cool the planet in another decade or so, it would be too late. The melting would continue. There are a variety of problems with that. Of course, sea level rise is one, but we also have a decent probability of fundamentally changing the circulation of the oceans of the Earth when we add so much fresh water from melting ice. That would be a disaster for our climate, causing massive droughts in places where we can't afford droughts, floods in places where we can't afford to have floods. Another issue associated with this warming is the possibility of melting what we call methane clathrates. And methane clathrates are a form of frozen methane. They're deep in the tundra. They're in the continental shelves of the Earth's oceans. And as long as we keep the planet at its temperature it's at now or cooler, they'll remain in ice form. But if we warm the oceans, if we start to melt the permafrost of the tundra, we run a very high risk of melting these methane clathrates and throwing massive amounts of methane into the atmosphere. And of course, methane is a very potent greenhouse gas, so we have a high probability of runaway global warming. So where are we now in terms of warming? We've warmed the Earth a little bit over 1 degree above the pre-industrial baseline, and we're already seeing problems associated with that. We're on target to hit that 1.5 degree range within the next decade, perhaps as soon as 5 to 6 years from now. And for the 2 degree range, given current warming, we'll be there within 20 years or less. And again, we want to keep the Earth well below that 2 degrees Celsius. I think it's important to note that the Earth warmed last year to the highest temperature we've seen in the last 500,000 years. The year before that was the warmest on record before that time. The rate of warming is in fact accelerating, and it's accelerating faster than any of the major climate models would have predicted even a few years ago. And the work of Jim Hansen, one of the world's premier climate scientists, and others now points to methane as being the culprit for this unexpected acceleration in warming we've seen over the last particularly 5 to 6 years. The good news on global warming is that emissions of carbon dioxide from our use of fossil fuels are actually leveling off. They have not gone up for the last few years. The bad news is that methane emissions are increasing, and methane concentrations are now rising at the most rapid rate ever. And methane is a greenhouse gas that is 105-fold more potent than carbon dioxide, so this increase in methane is a huge problem. Where's the methane coming from? There's still some disagreement in the scientific community, but I believe the best evidence points to the shale gas revolution in the United States as being the primary source. When we look at natural gas in the United States, 10 years ago, it was all from conventional sources. Now, over 60% of it is coming from shale gas. And we're seeing that spread into Canada and perhaps elsewhere into the world. You have some methane emissions associated with any development of natural gas, but the best evidence suggests that when we develop shale gas, it's a messy process, and we're probably increasing the methane emissions to the atmosphere by 3-fold over conventional natural gas. The work of Oliver Schneising, a professor at the University of Bremen, using satellite data, shows that most of the methane increase we've seen over the last decade is clearly coming from increased emissions from the United States and probably from the shale gas and shale oil fields of the United States. When we look at these methane emissions, there are two considerations. One is that when we use natural gas as a fuel, it actually releases less carbon dioxide than does coal. So that's the good news, and some have argued that we should wean ourselves from coal, but we can continue to use natural gas as a fuel, as a bridge fuel into the future with lower CO2 emissions. It's true the CO2 emissions are less, but natural gas is mostly methane. And again, the methane emissions, particularly as we move to shale gas, are quite large. So when we include the methane emissions from using shale gas, its greenhouse gas footprint is in fact significantly larger than that of coal, even though the CO2 emissions are less. Finally, we should look at the similarities and the differences in carbon dioxide and methane as greenhouse gases. They're the two major drivers of global warming. They're both carbon gases. The bad news about carbon dioxide is that when we put it into the atmosphere, it'll be with us for centuries, perhaps a millennium into the future. And the climate responds very slowly. So if we reduce carbon dioxide emissions now, it'll actually take 30 years or more before we see a slowing in the rate of global warming. Methane is fundamentally different in that it really only influences the climate directly for a decade or so, and then it's gone from the atmosphere. It becomes carbon dioxide. While it's there in the atmosphere, it's 105-fold more potent as a greenhouse gas. And unlike CO2, if we reduce methane emissions, the climate responds very, very quickly. So in fact, if we want to reach that COP21 target and keep the Earth well below 2 degrees Celsius, we cannot do so by reducing carbon dioxide emissions. The only way to do so is by reducing methane emissions. And again, the major driver of the current increase in methane emissions seems to be shale gas development in North America. Let me just conclude by saying that if we are to meet the COP21 targets, the world needs to be largely fossil fuel free by 2050. And given the role of the United States and Europe in the past global warming and our emissions to date, as a matter of equity, Europe and the United States need to be largely fossil fuel free by 2035. That means weaning ourselves of coal and oil for sure, but also in particular natural gas so that we reduce our methane emissions. That is the only way we can reduce the risk of irreversible global warming over the coming decades. Thank you very much again for the chance to talk to you today. Sorry I'm not there in person. Gracias.